Here we go. Common factor. So here there's an x in common all the way across. If I take that out, what's left behind is quadratic. So when we split those up, because we've got a product equal to 0, we use the zero product property to split things up. We get a linear factor, which is easy enough to deal with. And then we get a quadratic, and we know everything there is to know about solving quadratics. So we get our 3 solutions then. So first thing to look for would be common factor all the way across. That's kind of, low-hanging fruit, right? If we can do that, then, that simplifies things for us. We also looked at factoring by grouping. The way factoring by grouping works is that we don't have a common factor all the way across, but we can sort of pair terms up and find common factors within those. So here I looked at the first 2 and took out x squared. I looked at the second 2 and took out negative 64. And what was left behind is an identical factor of x minus 1. Well, then we factor that out. We've got a factored thing now equal to 0. So again, I can use zero product property to split things up. When we split things up, we've got a linear term that we can deal with easily enough. And then we've got a quadratic term that we can solve. I solved this by moving the 64 over and then taking a square root. When you do that, you pick up a plus or minus. You could do quadratic formula, or you could factor that, or however you want to go about solving this is fine. Because again, it's quadratic and you know everything about solving quadratics. Okay, and then the last one that we looked at was this x to the 4th minus 6x squared. And basically what we did is factor the trinomial just like you would factor anything else, just like you would factor a quadratic. Plus 5 in the sort of like C position means we're looking for something that are looking for 2 numbers that multiply to 5. Well, 1 and 5. And we want them to add to negative 6, so both negative would work. I don't remember if we did it this way in here or if this is the 1230 version of it, but what we did there is use that to actually split the middle term up and then factor by grouping. But whatever version of factoring that trinomial works for you is fine. You could also, we'll just walk through this real quick for the sake of doing it. You could also, once you recognize this sort of quadratic form thing, right, that like that leading term x to the 4th is twice as big as the middle term, x squared. So it's sort of got the same shape as a quadratic, but the powers are wrong. Again, that's what I mean when I say quadratic form, right? It's kind of the same shape. There's just an adjustment that needs to happen. Well, this is quadratic in terms of x squared, right? So I could use the quadratic formula instead. It's just that instead of x equals negative b plus or minus the square root of b squared minus 4ac over 2a, it would be x squared. Right? So it would match like that middle term because things are in terms of x squared. So 6 and 36 minus 20 over 2. They're okay with me doing a slightly, quicker version of writing stuff out. That's not it. 6 minus 4 is 2. So 5 and 1. And then the only thing we would do differently is we're not quite done yet. X squared is 5, x squared is 1. So x is plus or minus the square root of 5 and plus or minus 1. Taking a square root of both sides, put the square root of 1 is 1. So 1, 2, 3, 4 solutions. Those are the same ones that we got yesterday when we factored. So that works as well. If you're more comfortable doing that than factoring. But the basic idea is that we treat it like it's quadratic, only we make an adjustment because the powers are x to the 4th and x squared. That means it's quadratic in terms of x squared. So we get this sort of last step where we do a square root. Okay. So let's take 10-ish minutes. You guys take a look at and go ahead and get into groups and stuff. I know that some of you have moved. 2, 4, and 6. Again, think of these as practice. I'm kind of telling you, like, 2 is going to look a lot like 1, 4 is going to look a lot like 3, 6 is going to look a lot like 5. But try to take a look at them also and figure out, like, okay, what do I need to, look for here that's going to clue me into, doing things a certain way. Was that? No. Okay. I would subtract this over first, because if you're talking about factoring stuff out, it's only going to help factor that out. If the goal is to end up with a product equal 0 for that everywhere. So first step is That was good. We can take 19 out of 57. You're factoring that, right? So factor 19 out of that term. If you take 19 out of 57, so 57,000. So if you multiply this back, if you distribute this back through, take -64x out here, back to the same problem. X, right? That's what we need. Yeah. So we can figure it out. Okay. So if you try to factor in the two numbers that multiply.
Oh, and
So, yeah. So if they can multiply 100, it adds. Oh, 4a. Okay. Yes. B squared. Oh, actually. So B squared minus 4a. Right. Yeah. So if you're gonna try to factor, notify the number that reply, you need 8 times C. So we're use 5, so 100 and add. Can't come up with those, you don't want to mess with it or whatever. The quadratic formula instead, and just have, you know, like we did on the last one, use x squared. Okay. All right, so just kind of real quick, we won't like work all 3 of those, you know, all the way out or anything, but first thing would be to get everything on one side, right? Because we can't really, you know, most of our methods kind of rely on having that equal 0 over there, especially talking about factoring. So would subtract that 10x squared over. I went ahead, you know, stuck it in the middle, so things are in descending order. That's not super important, but and then everything's got a common factor of x, so take it out. And you're looking at sorry, something is happening here. You're looking at x times a quadratic equal to 0. That means that, think about applying the zero product property, either x equals 0 or 3x squared minus 10x plus 3 equals 0. Well, you've got one solution here. The others just solve that quadratic. I don't know what they are. Does anybody have them? 1/3 and 3. Okay. So there's 1, 2, 3 solutions. But again, the way we got into the problem was taking that common factor out. Right? So there is a common factor of x all the way across, take it out, and we're in good shape. How about number 4? Again, I know I'm going through just kind of high level overview and quickly, but more detailed solutions are in Blackboard, so keep that in mind. 4. Yeah, see if you can group it, right? Basically, if you see a thing that's got 4 terms like that, grouping should be kind of your first thought. So that's the first thing I'm going to try here. What do those have in common? If you take x squared out, you're left with x plus 3. And what does the second, the second pair of terms, what do they have in common? I mean, 19 should be the thing that kind of jumps out at us. So if this is going to work, what I would want to check is that 19 goes into 57. It does 3 times. So if we take negative 19 here, then what's left would be x plus 3. And that's the thing that we're kind of looking for, right? This and this to match. If they don't match, then it's not going to work. They do, though. They're identical. So x plus 3 times x squared minus 19 equals 0, right? So the other things are kind of what's left behind when you factor the x plus 3 out. You're left with that. And then again, we've got a product equal to 0, so we're in good shape. So you'll get negative 3, the square root of 19, and negative square root of 19 as solutions. And again, I'm omitting a little bit of stuff there, right? Okay, everybody feel good about those? Anything we need to talk about? All right. The last one, again, I would probably look first at that, right? 4th power, 2nd power, and then a constant term. So this is a thing that I can treat like it's quadratic. We can either try to factor it, which is a little bit harder here because the coefficients are, bigger, right? Or we could do quadratic formula. If you're going to try to factor, you're looking for 2 numbers that multiply to give you AC, right? So multiply to give you 100, 4 times 25, and add to give you B, which is negative 29. Like I said, it's a little bit more involved. Factors of 100, right? There's kind of a bunch of those. Add to give you negative 29. Turns out negative 4 and negative 25 work. But you are, well within your rights to not, to see that and say, like, I'm not going to worry about trying to factor that. If you want to, there you go. That's what you use. Or quadratic formula, and you would just do quadratic formula to find x squared. This would be 29 plus or minus the square root of b squared, 4 times a times c over 2a. So 29 plus or minus the square root of I don't know what 29 squared is. That's 400. Okay. 441, is that a perfect square? Oh, 21. Okay, yeah. And then simplify from there. So it looks for a little bit like it's going to get real messy, but it actually doesn't end up being that bad. The numbers are big, you have a calculator, so it's fine, right? This looks like it's going to be real scary, but that ends up being a perfect square. So add and subtract, and you're fine. You get 50 over 8, 25 over 4, and 1, I guess, the solutions. And then you take a square root, right? This is messier than something that I would give you on like a test question, but you know, it should be within reach if you have time to, you know, sit down and work through it a little bit. Okay. Flip over the back. If we can solve equations, then we can solve inequalities, right? Especially if we can solve equations and we know stuff about how to graph the function that it goes with. So this is just a reminder. Here's how we solve inequalities. Solve the equation first. Plot your zeros, you know, on a number line or however you want to do it to keep things organized. And then either think about the graph or pick test values to check to see what's going on. So again, I'm not going to solve this as an inequality. I'm going to solve it as an equation first. So how would we solve x cubed minus 5x squared minus 6x equals 0? What can we do there? Take out an x, right? There's a common factor of x all the way across, so take it out. Then again, you've got a product equal to 0. So x is 0, or x squared minus 5x minus 6 is 0. This is going to be one of our solutions, one of our points that we need to pay attention to. And then the other two will come from this. So now you got to solve this quadratic formula or factoring. Again, I'm doing the slightly quicker version of that so that we can get to the meat of the problem. But solve that for yourself, however you're comfortable doing it. So we've got 0, 6, and -1 as places where this thing is equal to 0, right? So if we're thinking about the cubic thing on the left-hand side as a function, we've got its x-intercept now, right? We have its zeros. -1, 5. Yes, okay. For the inequality, here's a number line. I'm going to plot those, -1 and 0 and 6. As usual, those kind of break everything up into pieces. So how many intervals do we have now that we're checking or thinking about or testing to see what this thing does? 1, 2, 3, 4, right? 3 zeros, 3 intercepts, which means there are 4 intervals I got to think about. Each of those intervals we want to decide, like, is the inequality true or false, right? So, as usual, we can do that one or two ways. We need to think about the graph. Think about this, y equals x cubed minus 5x squared minus 6x. Think about the graph of that function. It's cubic. So what do the ends do? Same direction or opposite? Opposite ways. Leading coefficient's positive, so which way? Winds up pointing up. Okay, so the ends look like that, right? This is where all of that, graphing stuff that, I understand you may not have had a ton of time with just yet. So hopefully this will all kind of start to gel in the next couple of days as you work through that. But the ends of that function look like this. It's degree 3, right? It's cubic. So how many intercepts can it have? No more than 3, right? And this one actually has 3. So that means they've all got to be just multiplicity 1, right? They've all got to be just like simple crossings. So what this thing looks like then, if it's got ends that look like that and simple straight across intercepts at those 3 points, is that it looks something like this. Let me draw it more exaggerated. Right, it looks something like that. I don't know exactly how tall the these like bumps in the middle are, but that's okay. I don't care either, right? Because what I need to know is where is it positive or negative, right? We're comparing it to 0. Comparing it to 0 just means is it on the upper half of the plane or the lower half? Is it above the x-axis or below? We want to know specifically where this is less than or equal to 0. Less than or equal to 0 means sitting underneath the x-axis. So if the graph looks like that, what happens on this first interval to the left of -1? The inequality through there? Yeah, because it's sitting underneath the axis, right? And then it crosses, and now it's sitting above. So the inequality would be false. And then it crosses again, it's sitting underneath, so it's true. And then it crosses one more time and it's sitting above, so it's false. So our solution set would be this stuff and this stuff. So how do we write that down? Right, write your solution in interval notation. How do we do that? First piece would be the stuff to the left of -1. Right, how you write everything left of -1. Negative infinity to -1. Include or not? Brackets or parentheses? Bracket because or equal to, right? Okay. And then we skip over some stuff and then we pick it up again later. So union. Everything between 0 and 6. Closed interval 0, 6. Now, if you're more comfortable with the testing points idea than the graphing thing, that's fine, right? You can do that too, or instead, you don't need to do it also. You can do that instead. You would need to test something from each of these 4 intervals, right? So like -2, -1 and 0. So you're going to have to use something like -0.5, 2 and 7 or something like that. You could test those. You'll get the same result, right? You'll draw the same conclusion that you get something here that's true in that inequality, and false, and true, and false. Again, one more, plug for like, don't assume it's going to alternate, right? For a couple of reasons. One, if I'm grading it, I'm going to want to see that you actually, tested each interval somehow. But also, it's not always going to alternate, right? Think about some of the graphs that the graph that we talked about yesterday. If you have something where there's some kind of like even multiplicity thing, well, it's not actually going to cross the axis there, right? It's just going to bounce and turn off. That means it's not going to alternate true, false, right? Okay, so questions about any of that? Do you see it, that this is not really any different than places that we've talked about inequalities before? The only thing that's different is really this first step where we took out a common factor. So like the solving part might be a little bit different, solving the equation, but the big picture, we're doing the same thing. Figure out where the zeros are, then figure out what happens around them. But then write down your answer, right? So if you're good with kind of the big picture idea of how we're solving inequalities, this shouldn't really be anything new except for the first part where you're solving stuff. If you're not, then come talk to me because it's just going to keep being a problem if you still feel like you're sort of lost in the second half of this and how we're solving that. That's going to keep being a problem, and it's only going to get worse as we go along and things get kind of more complicated. So come talk to me about it. There's another one there, number 8. Do that one on your own. We'll talk about that Thursday if we need to. Thursday, we will also go on and talk about polynomial division. So what do you do if none of these factoring tricks work? And that is all. So you guys have a good day. I'll see you on Thursday.